Okay. Now I think... Alright, well, I assumed you can hear me. I forgot to plug in my microphone, so hopefully you can hear me now. Alright, well, I'm hearing myself, so I guess I am live. Good evening, Tiffany and the Shih Tzu. Yes, I have just barely begun, in fact. Good evening, everyone, from the Eastern California desert. My name is Mike Jerry, and welcome to my live stream. We're going to see some neat stuff tonight using the Cloudy Nights December Observing Challenge. And when I set this up this morning and set the live stream and broadcasted it out and announced it to the world, the forecast was calling for 10% cloud. Well, a few hours later they changed it to 30% cloud. Seems pretty clear right now, but we may run into some cloudiness here a little bit later on, but well, we'll do the best we can with what we got here. Okay, let me now turn that off, and we'll go here to our screen. And I just started on a random object. This actually isn't in the observing challenge, but it's one of my favorite objects, and that is the Veil Nebula. In this case, the West Veil Nebula. And why is the history... Whoa! Wow! Oh yes, and you forgot something. I forgot to put my flat in. That's what it looks like when you don't use a flat. Shoot, well, okay. I guess we're just gonna clear this all out anyway, but it's a very nice, very pretty little galaxy nebula. And it's a summer nebula, actually. It's getting kind of low in the sky now, but early in the evening we can still get a hold of it. Let me make sure this is all working correctly now that I have the correct flat installed here. So we don't have that big glowing spot in the middle. Yeah, that looks a lot better. Balance the colors again. Balance the histogram again. And now we'll take this and stretch it out a bunch. Yeah, now we should have some nice colors in here. And if we had more time, well, we could give it a few minutes. We should have enough time for a little bit here. Then we'll get started on the actual challenge, but I really do love the Veil Nebula. And so I like, whenever I can get a chance to look at it, I do. Let's put you out of the way and expand you a bit more. But this one is the brighter spot, a brighter spot in it. It's actually a whole large object that was a supernova that blew up about 15,000 years ago. Oh, and this is what, early in the evening, this is what we're going to get a lot of satellites. Satellites blasting through our image. So we'll just have to unstack those and continue on. I hope we don't get too overwhelmed with them. Early in the evening the satellites will show up. As we get later into the evening, they'll become less and less, but right now the satellites are still in the sun, because the sun it's only about an hour and a half below the horizon, so it's dark here, but those satellites way up there are still seeing the sun. So when we point west low in the horizon in the evenings, we get lots of satellites. But this is it's a supernova remnant. It's a very large area of the sky that it's about 3 degrees in diameter, and this was all part of one star. That does need to be adjusted. This was all part of one star 15,000 years ago when it all blew up. Hey Daryl, thanks for coming by. We are starting on a bonus object, so this actually isn't in the challenge, but since I was right here anyway, I used Deneb as my focusing star, so right next door is the beautiful Veil Nebula that I just can't pass up an opportunity to look at. So that's what we're doing here in the moment. And we'll get to our challenge here. I'll put about 10 minutes into this or so, and then we'll get to that. But yeah, this was a supernova. All this gas, this is, and I'll show you in fact on Stellarium here, and I should shrink this down so you guys can see this whole window, because on the broadcast you can't see this whole window. So this whole circular area, there we go, that's good enough. So this whole circular area here, this whole big area here was all one star, one massive star that went supernova, and about 15,000 years ago, and so it has just, these are all the gases and dust that are just blowing out away from it over the last 15,000 years, and this is it's a 3-degree section of the sky, so it's really, really big. And it's just really beautiful. This is called also the Witch's Broom, which you can kind of see there why it would be called that. And then down here is Pickering's or Fleming's Triangle, depending on who you credit the the discovery to. It was actually discovered by a woman astronomer named Fleming back about a century or so ago. But the lead on the project was a man named Pickering, and in those days, well, the men liked to take credit. Well, we still do, but this case it was just unfairly taken credit for, so it's called Pickering's Triangle, but it's really actually Fleming's Triangle, because she discovered it and told him about it, and then he told the world. But because he's the one with the reputation, he got to get the credit. Alright, let's adjust this a little bit, bring that blue back down because it's always just a little high, and stretch it a little more. And you can start to see some of this wispiness down on the bottom starting to come in. This is actually a lot better with a dual band filter that allows the frequencies of light that are the nebulae, so the red is hydrogen and the bluish green is oxygen. And so you use what's called a dual band narrowband filter that allows those to come through but cuts back every other all the rest of the spectrum of light. So all these stars get cut way, way back. The smallest ones disappear entirely. The bigger ones get reduced significantly in size. And it gives you the impression that the galaxy or the nebula pops forward, but in reality all you're doing is cutting everything else back. So it is better to use a narrowband filter on these, but it's still pretty even with just regular unfiltered. Well, we only got one sub with a satellite in it, so far we're doing pretty good. Here on the west side of the meridian, this close after sunset, you can always get lots of satellites. But so far so good. And like I said, this is a summer object, so it's getting low in the sky and won't be visible for very much longer. In fact, this is probably the last month it's, well, yeah, this is probably the last month that it's going to be visible. Maybe a little bit next month, but then as the days get longer and the sunsets get later, this is sinking lower in the sky, it's going to disappear quick now that we've gone by the winter solstice. And our days are going to start getting longer again as we start crawling our way out of winter slowly over the next few months. Anyway, good evening, everyone. It's a pretty nice night here in Eastern California. As I was saying earlier, we should have a nice night. When I set this live stream this morning and broadcasted it out, they were saying 10% clouds. A few hours later, after I did all that, they changed it to 30% clouds. So we may see some, I mean, it looks pretty good now. Hopefully the first forecast was right and the second one is wrong. But if we get some wispy clouds flying around, we may lose some subs and have some fuzzier images than we should, but it shouldn't be too bad. Now that we've got several of these, we can kind of zoom in on this guy. You can kind of see the lacy nebulosity and the flowingness of it. They're actually quite beautiful. The red and the blue is quite beautiful, and it's just sort of a lacy, flowing sort of pattern, which is why it's called a veil. It's like sort of a silken veil in texture. I don't know, when I'm monitoring my own broadcast, and it's looking kind of greenish on the broadcast, so I'm wondering if I should put that blue back that I stole away. See what you guys think. Let me know if you think it's too blue. But the broadcast looks like it's kind of changing it to being a little too greenish. On my screen it looks plenty blue, but the compression algorithms used by the by YouTube can change the way things look. So and of course there's a delay between my actually broadcasting it and making the changes and the effects to show up. It's like 30 or 45 seconds, so I just now got to see my changes, and it does look a lot more blue, which is how it's supposed to be. So I think we just need to leave it with the blue. Yeah, I think this is a more accurate color on your end than what it was before. Okay. Okay, I know now while we're letting this finish up here, I know one thing I also need to do, and that is I need to get our list brought in for the night. I need to import a list. So I make the whole list of all the objects, and then in Stellarium, I make an observation list out of it. And there it is. And there it is. We can highlight all and close this up. And now all of our objects will have these blue spinning circles around them. So we're going to start right next door here on M15 and then work our way up. This one might be a little tough. It's very faint, but we'll give it a try. This is a planetary nebula. In fact, while we're waiting on that, let me get See how you're doing. You're going pretty well. Let me get the challenge itself up. This, and this. And there we are. So here is the challenge set up by Brent. Planetary nebulae, star clusters, regular nebulae, and galaxies. We've got several galaxies in here. And he has some southern targets, one of which I am south enough to get. I'll be able to get this first one in Fornax. So we should be able to see that one as well. But we're going to start off with M15 and friends. Oh, there's a satellite. Oh well, we're done with this anyway. So it's time to get on to our first target, which is going to be M15 over here. So let's go say goodnight to the beautiful West Vale Nebula and move on to the next. M15, really nice globular cluster. Yep, there it is right there. Okay, we can plate solve to center that up. There we go. That'll bring that right into the center. There we are. Okay, and now, well, now what I'm going to need to do actually is I'm going to need to change out. We are not going to need 1 minute. We are not going to need 1 minute on our okay, and we'll start imaging. Where are we? This is way too much. Maybe we'll be okay with that, right like that. Okay. Let's bring you in here. Like this. Bring this over here. It's probably a little bit blown out. I'll probably have to back some of that stretch off, but you'll get the idea. I'm going to clear this and restart because we had a little bit of what looks like mount movement. And in the meantime, while that's building, we're going to do Wikipedia and Messier 15. Okay. Wow. Boy. Why did that change so much? I wonder why. Okay, Messier 15. Also called the Great Pegasus Great Pegasus Cluster. It was discovered by Jean-Dominique Maraldi in 1746. Included in Charles Messier's catalog of comet-like objects in 1764, which is why it's called M15, short for Messier 15. At an estimated 12.5 billion years old, it's one of the oldest known globular clusters. It's about 35,700 light years away from Earth, or about a third of the distance across the Milky Way. And it's 175 light years in diameter. It's one of the most densely packed globular clusters known in the Milky Way galaxy. Its core has undergone a contraction known as a core collapse, and it has a central density cusp with an enormous number of stars surrounding what may be a central black hole. It has over 100,000 stars in it, and has a whole bunch of variable stars. And it contains the first planetary nebula discovered within a globular cluster. Fun. So it's about 100,000 stars in this thing. Let's see what Brent had to say about it. Beautiful glob, an area to explore, very small and very large scale. You can try for the small planetary P1. This was the first planetary ever discovered in a glob. Found it photographically. Interstellar flux nebula from N15 all the way to Enif. So between here and here. Look at that satellite. Don't know if we're going to get an interstellar flux galaxy, but well, we can try stretching. Oh, why not? Interstellar flux nebula. Oh. Battery needs some charging. It's like yellow up there. Can't really tell. Don't know that we're going to see much of this nebula. I probably don't have long enough exposures to find it. Looks like there's some haze or fuzz over here. That could be anything. Well, let's see. Where is Enif in respect to this? Pull up our annotation. Let's see. Enif in here. Maybe too far out of the view. Galaxy, 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 galaxy. Yeah, I don't know. Not seeing it. Yeah, we've got more satellites just blazing through everywhere. But it is a very beautiful cluster. And it's a great telescope target. I think this is probably what they're talking about here. This fuzzy, hazy stuff. But I can't really tell from... There's too many stars in here. Well, actually, if I had done this... Okay, first of all, we're way off. Let's get that right. It's HIP 106243. Is that this one? Nope. It's this one. Yeah, this is so nice and blue. Okay, so this is the yellow one over here. Problem is this thing flips it, so I don't know, too hard to figure out. I think this might be some of it here, but I don't know which direction is what. So, and there's a satellite now going directly through the object. Yeah, and I can't get rid of it now, so it's a done deal. Anyway, M15 is a very nice target. And the nice star colors we're getting on all the other stars around are pretty cool. Alright, well the next target for the night is going to be to the right. Yeah, so no, it's to this. So no, it would be in this direction. Actually, it would be toward the star, because this blue star, 106243, is in the direction of Enif, so it would be down this direction. If we were getting any of it, it would be down in that direction. I'm not seeing much of anything there. But again, I'm not really stretched for, I'm not really set up to for nebula on this. I'm got very short exposure to be able to not blow out the core of the cluster too much. In fact, now that we're zoom in a little bit more and back this off, get a little more of the stars. There's 100,000 stars in there. Alright. Let's see if we can pick up this planetary nebula. This will be a very small object, and so may or may not be able to see it. I think I will turn back up to a minute of exposure time. And can't forget to put my flat back in. Yeah, let's start deleting some of these old flats that I just don't need anymore. Alright. Did I do this? I don't remember what I did. Didn't look like live stacking was on, so I don't think I did do it. Alright, let's see. Let's see what our... Well, we got a nice satellite. Surprise, surprise, surprise. We got a very nice satellite. Oh yes. And there it is, right there. See that pretty little circle right in there? It is a beaut. Look at that. What a nice bubble that is. As we collect some more subs, we'll be able to see that a little better, but that is a nice one. So a planetary nebula actually has nothing to do with planets. It was called a planetary nebula because hundreds of years ago when they were first discovered, the astronomers could tell that they weren't stars. They were actually round, not just point sources of light like most stars are, well, like all stars are. Stars are so far away that even though they are massive and huge high-energy objects, they're so far away that they're never more than points of light. The reason they become disks and spheres in long exposure photography, like what we're doing, and even what they did back then, is because the light just it saturates the pixels surrounding it, and the longer the exposures that you take, the more pixels that get saturated, and so it turns into a disk, even though it's not. Stars are all true points of light. If you look through a telescope, they're true points of light. They never really get more than that. They can get bigger and brighter, but they never really become disks like you see in images. So when they first saw when they saw the first planetary nebulae, they could tell they weren't points. They could tell that, number one, they had shape, they were round or spherical or something, and they had a nice, pretty color to them. They were typically not, light colors like a bluish or a yellowish or whatever from a star. They could tell that they had more saturated colors. So they looked to them like maybe they were planets. So they called them planetary nebulae, and because they weren't really sure, and so they just kind of named it that. And so when so later on, when we discovered what they were, well, the name kind of stuck, obviously, because that's what they were. They were named planetary nebulae, and that's what we think of them as. But what they actually are is the death process of normal main sequence stars like our own sun. In about 4.5 billion years, when our sun starts getting really old, it starts running out of its fuel, and it starts shrinking and compressing in on itself, which causes it to change fuel sources, and then it starts blowing away its outer core, and the star actually just starts expanding and expanding. And so our sun, in about 4.5 million years, will turn into a red giant. The outer layers of the solar mass will just start expanding outward from the star. Once it's burned up almost all of its fuel, it loses a lot of its gravity too. So that's another reason why it starts expanding outward. And so as it expands outward, it gets bigger and bigger and bigger. It turns into what's called a red giant. In fact, it may get so big that it could even consume the orbit of the Earth, is how big they get. And so that expansion just continues. The star continues to burn, the core stays behind and continues to burn, just much more dimly than it used to. It turns into what's usually a brown dwarf. And it stays behind and continues to burn just more dimly than it used to. But what happens is that then illuminates all the gases that are expanding outward as the star continues to blow off its outer layers. And so that's what we actually see as a planetary nebula, is those outer, all that gas being blown away from the star and being illuminated, irradiated by the brown dwarf, or whatever is left of the stellar core that's still burning, that got left behind. This one looks like a pretty cool sphere. It looks very, very round, but some are not round. Some will, depending on the magnetic field of the star itself, depending on the gravitic influence of other celestial bodies around it, they can have all kinds of weird shapes. So this one just seems to be a really nice example of a nice circle, a nice sphere expanding outward from the center. So, nice object. This is about as far as I want to zoom in on anything, because I am a small focal length and wide field, but wow, when did that satellite show up? I didn't even notice that. Let's unstack one and see if it was the latest one. Yeah, good, it was. I was so busy jibber jabbering I didn't even notice it come in. But nice little object. Let's see what he has to say about it. Planetaries. IFN in this area as well. A wide field rig might be able to get the planetary and nearby M15. No, that's too big for us. But a very nice little little object. Oh, hey Don. Thanks for coming by. Did I add you to my broadcast list? I'm scratching my head as to how you heard about my my live stream. Probably turn on the music for you guys for the quiet moments. Yeah, I did see that you were on NSN casting. I didn't know that you knew about my broadcasts, so maybe you've subscribed to me or something. But hey, thanks for stopping by. I appreciate even while you're casting coming here to check this out. Oops, sorry. SH2200, I don't think so, no. This is NG 7094. Planetary nebula right next to M15 in Pegasus. So, getting a little low in the sky for us, but oh, somebody was doing a live stream from their sea star. Yeah, why not? Thanks, Don. I'll check you out later. And welcome, Chris. So we just got a nice little few minutes on this planetary nebula here. NGC 7094. Turned out to be a nice little one. If we were going to get any detail out of this, I'd have to set my scope up a little differently. More focal length to get zoomed in there better, but this is a nice looking planetary. I don't know that I've seen this one before. We'll finish out this sub and then we'll see what's next. I think Caldwell 30 is next. A galaxy, if I remember. You know, I could see 7094. How far away is this? Distance. About 4,500 light years. About 4,500 light years away. And this is most probably a foreground star. A star that's between that galaxy, or that nebula, and us. This could be the central core star of the planetary, although it looks a little bright, but yeah, it could be. Chris, I'm using a C8, a Celestron 8-inch Schmidt-Cassegrain telescope with a Hyperstar in the front of it. If you scroll down to the description of my live stream, it tells you all the hardware and software that I'm using to bring you the broadcast. Yeah, see, if we spent enough time on this, we might actually see some detail in this. But what we really need is more focal length. That's certainly way more than I should be zoomed in because it gets all pixelated and whatnot. But yeah, for 400 millimeters of focal length, that's not doing too bad a job. That's pretty cool. Alright, let's go on to our next object, which I think is our first galaxy. Yeah, Caldwell 30, right up here. The Deer Lit group. Now this is definitely going to be a bunch of really small stuff. Really small targets. But there's a bunch of galaxies in here. Let's plate solve on that to make sure we bring it into the center of the field of view. That's definitely one of them there. Probably bring that guy right down here into the middle. Yep, and it did. Okay, and now let's do this. And we'll see what happens here. I do have, yep, got that flat on there. The Deer Lit group is just it's a collection of galaxies, just a whole bunch of galaxies next to each other. Again, really small targets, but I'll bring up the annotation and show you how many galaxies there are, because there's a whole bunch. But we'll be able to see a good number of them, certainly not all of them very well. Most of them will just be little smudges or spots. But we'll be able to see at least a few of them. Right now, Chris, I'm doing 60-second exposures, but depending on the object, I change that up. When I'm doing the globular clusters, I'm only using like 15-second exposures. So yeah, you can see there's a little group there and there. Certainly this is the big one. One there. There's a whole bunch of galaxies in here. I'll kind of just zoom in on this little group here until we get some more subs in. But yeah, there's definitely one there. Looks like there's one there maybe. Yeah, this is a whole grip of them in here. And another bunch of them out here. Yeah, I'm using anywhere from between 15 and 60 seconds of exposure time. I typically don't need more than 60 seconds unless it's a very, very faint object, because I'm at a very fast focal ratio of 1.9, so I collect light real quickly. So I don't usually need to do more than 60 seconds of exposure. Yeah. Just to show you, let's bring up. So here in this view is how many are in here, and then if I zoom out, we get a few more around the periphery. And this is all the galaxies in this picture that, well, actually that's, but there's a lot more galaxies here than this. Number one, because this galaxy catalog only goes down to Mag 18, so only the brightest of the galaxies are showing up here, not the dim ones, not all of them. And number two, the resolution of the annotation can only go so far. So it says there's a group here, and it says there's one here. But the fact is, if we it only says there's like one here. But if we were to zoom in, all of a sudden more are going to start popping up, and more are going to start popping up, and more are going to start popping up, because then the resolution of the annotation shows up. So there are quite a lot of galaxies in here. These are some really interesting looking ones up here. After we get some subs in, we'll go to 6-7 minutes. When things get a bit less grainy, then we'll zoom in more and look at them a bit more close up. The Deer Lit group, of which this is the primary member, obviously, it's the biggest and most obvious one, NGC 7331. This one is actually a foreground galaxy. It's very much closer than the rest of these, which is why it looks so much bigger. Let's see, what do we got? This is definitely a spiral galaxies. These galaxies lie at distances of approximately... So the galaxies that are here, these four galaxies here that are the smaller ones of this group, are between 300 and 365 million light years away. NGC 7331 is much closer. Say how far away 3331 is, but whoa, unstack, go away, you satellite trail, you. But yeah, these are 300 to 365 million light years away. This one is, much, much closer. Although I can't really see. Doesn't really seem to say. Let's see if I can get a picture of indication on this. It's 40 million light years away. So 40 million versus 300 plus million. So that's just why these are 8 times further away than this galaxy here. So as a group, they are actually called a virtual group because galaxies need to be within a couple of million light years away from each other to be considered in a group together. They have to have some sort of gravitational relationship to be in a group. These are just a visual group. They look like they're together, but they're not. This one here is much closer than the others. You certainly can start seeing some of the detail in this one. The wispy spiral arms coming out. Some of the knots of high energy, probably star forming regions in the galaxy here. It's a bit of a spiral and odd-shaped galaxy. See, here's a galaxy here. That one right there, that fuzzy ball right there is clearly a galaxy, but it may not even be in my catalog because it's probably fainter than... Oh, it is. It's Mag 16. It's a PGC galaxy. Mag 16 too. 15.8 there. Yeah, it is in there. This is the Deer Lick group, Scott, not the quintet. So this is the Deer Lick. And then, well, this down here has the Stephan's quintet. Yes. Okay. Yeah, so the one we are on is the Deer Lick group here. The one that we've got up here is Stephan's quintet. You were right. We're going to go look at that in a second. That's another cool one. But in the meantime, we're kind of checking this one out. You can see the detail really starting to form in this. Oh, there's another satellite. But that one's so faint. I'm gonna... Well, actually, does it go through the quintet? It does, sort of. Take it out. Erase it. Erase it. I should stop moving that screen around so much, because I know it pixelates for you guys when I do that, so... settle out for a few minutes for you guys. Ah, cool. Have you ever been to the Lick Observatory? I haven't. I assume they would do tours and stuff, though, if you wanted to go. Maybe I'm wrong. Let's go check out the quintet here for a couple of minutes. Cool little group of galaxies. Good. Well, I hope you go and check it out when they do. Interesting little thing here, whatever that is. But some nice color in these too. use a couple extra minutes, so I'll do that. It's kind of a bonus object anyway, because we're doing Stefan's quintet and the Dear Lit group, but why not? If it's all in the same view, why not get it? Let's see what he's got. Planetary galaxies are up here. Yep. Stefan's. That's a pretty cool little group. And then go back to our actual object here. Spend another minute or two on this. Head over to our next object. So again, this galaxy here, these aren't actually gravitationally grouped. This one is 40 million light years away, and these are all 300 to 365 million light years away. So this is a visual-only group, this one being very much in the foreground. But still a nice collection of galaxies here. Pretty neat little galaxy up there in 7331. A nice spiral. Nice example of a spiral galaxy. Finishing. Let's see where we're going next. Okay, we've done... Alright, we did M15 and 7094. Where are we going next? Caldwell 14. Oh no, we've got NGC 428 out here. Another galaxy. Yeah, this is an active galaxy that we're going to be doing next. Alright, let's say good night to the Dear Lit group and head to our next object, and here looks like Stellarium doesn't even have a picture of this one. Okay, our scope moves into place here. Let's plate solve our way in. Start our capture. Anything else to do on this side? Boy, all the rest of the stuff's getting very close to the meridian. Which means I need to either go over there really quick and catch them all, or wait for all of them to come over. The type of mount I'm using, an equatorial mount specifically, Can't really cross the meridian while tracking an object, so I will need to a meridian flip or something. And of course we've got a satellite, looks geosynchronous to me, going right through our deal here. Interesting looking galaxy, because I think it's, well, let's hope it's headed away and not through. Find out here in a second. Yes, it was headed down, not up, so that's a good thing. Okay, so this is NGC 428. Let's see. NGC 428 is a barred spiral in the constellation Cetus, with its spiral structure distorted and warped, possibly the result of the collision of two galaxies. There appears to be a substantial amount of star formation occurring within it, and it lacks well-defined arms, a telltale sign of a galaxy merger. In 2015, the Hubble Space Telescope made a close-up shot of the galaxy with its advanced camera for surveys, and its wide field and planetary camera too. Discovered by William Herschel in 1786. In 2013, there was a supernova in it, apparently. Another very small object, but we will do our best. Distance. It's about 48 million light years away. About 48 million. that structure. Take this one last sub here. And we got a decision to make. Some of these are getting pretty close. I'm going to do a meridian flip. It has to be now because Caldwell 14 and the double cluster is getting very close to the meridian. So I'm going to have to buzz there really quick before it goes over. Alright, there's 10 minutes on that galaxy, which is a pretty cool little galaxy. A little small for my setup, so we didn't get a lot of resolution with it, but works out. Okay, so now let's do a meridian flip. Okay, well, that went without a hitch. Oh, in fact, there it is right there. Got pretty darn close. Not bad for a big old swing around. No, that just dragged me way off target, didn't it? Yeah, that just dragged me completely off target. Okay, let's actually go to this star there, recenter on that, and send me there. That hopefully should bring it back. Yeah, and there's our double cluster. And in fact, I want to switch this. Again, we're doing a star cluster, so let's go with 15-second sub-exposures this time. Because with star clusters, they're very bright. You don't want to take too much for exposures because they will just blow everything out. one out. And reset this. But it is a beautiful... Hey, Pete! Thanks for stopping in. Happy New Year. Merry Christmas to you as well. This is a... Double cluster is a beautiful binocular target. It's just below Cassiopeia. And you're in relatively dark skies. You can see it naked eye as this fuzzy, sort of a double fuzzy spot in the sky. It's a very pretty pair of clusters. So we'll take a few minutes on those. Pete, are you guys gonna come out and visit here sometime this winter, or are you too busy running back and forth to SLC? This is a really pretty binocular target. Great to get out and see if you can. Actually, for those of you with clear skies to your east, right now there's a nice red planet rising. Mars looks great out there tonight. Just noticed it rising above my horizon and a little bit ago. Okay, so now what I need to do is I just need to watch my meridian so I don't go over it. And then we're going to have to go to... Oops, wrong way. We've got other objects here that I'm going to need to get to before we go over. It's like 67. Yeah, these are both about the same. Yeah, 1073. Well, the beauty of this cluster is that we don't have to spend a lot of time on it. The star clusters resolve very quickly because they are very bright objects. I wonder if Wikipedia has anything interesting to say about the double cluster. The double cluster consists of two open clusters, NGC 869 and 884, which are close together in the constellation of Perseus, both visible with the naked eye. The latitude distance is about 7,500 light years away. The bigger one has a mass of about 4,700 solar masses, and the other one 3,700. Both clusters are surrounded with a very extensive halo of stars. They form the core of Perseus OB1 association of hot young stars. Based on their individual stars, the clusters are relatively young, both 14 million years old. That is pretty young. In comparison, the Pleiades have an estimated age ranging from 75 to 150 million years. There are more than 300 blue-white supergiant stars in each of the clusters. The clusters are also blue-shifted, with NG 869 approaching the Earth at a speed of 39 kilometers per second, and 884 approaching at a speed of 38 kilometers a second. More than 300 blue-white supergiants. Massive stars. Fest. The Tacopa Fest or the Tacopa Takeover? The Tacopa Fest, which was the first weekend in November, I actually worked. I was working in the fire department. So that was a fire department fundraiser. The Tacopa takeover was the following weekend, and I was so burned out from the Tacopa Fest that I did not go to the takeover. There we go. Well, 5 minutes. I think that's pretty good on this cluster. This little cluster of stars there. Blue-white supergiants. Plenty of yellow ones in there too, although some of those may be foreground stars. The fest, okay. Well, gosh, I didn't see you guys. How did I miss you? I worked the whole day in the fire department fundraiser booth, selling T-shirts and caps for the fire department. Oh well. I was busier than a one-armed paper hanger, so wouldn't have been able to chat anyway. Okay, well, there is the double cluster. That is a good one there. Alright, well, we may just... I have to come back to SH200 because we're going to lose these guys. These guys are going to cross the meridian, and I don't want that to happen. So I need to... There we go. And let's go ahead and slew to that. Basically just got a tightrope right along the meridian. Okay. Yeah, it says we're right there. Okay. That zip right to where it needs to be. Oh. But again, we're a faint target, so now we're going to switch back to 60-second subs. Go, and then I have to put the flats back on. I didn't notice it for the 15-second subs because they weren't long enough. Yeah, yep, that was the one. I was there. Oh well. We missed each other this time. Bonus. Just barely caught an edge-on spiral down here. Bonus. Just barely caught an edge-on spiral down there. Isn't that cool? Well, we'll keep that in the picture. We'll have them both. This is the one we're after here. This is a pretty cool looking one down here. Ah! Fingers in wrong places. Come on, where's the button? Yeah, it's right down here, whatever it is. NGC 1055 is what that one is. That's NGC 1050. Oh, and then M77 is right here, right just below us. Gosh, we could have gotten a threefer. See if I had done that. Could have gotten a threefer. Still can. We're not that far into it. We're not that far into it. So now it's going to be a threefer. A hat trick. An astronomical hat trick. We'll get M77 in there and 1055. Get them all in there. Hardest part is waiting for the first sub to show up. $273. Yeah. Okay, there's all three of them. But of course a satellite bombing through the middle. Couldn't have an image without one of those. Alright. Here's our trifecta. So we've got all three of them. So, 1073, it's a barred spiral, so you can see the little bar right in there. So it's a bar, a barred core, and the spiral on the outside. And it's about 55 million light years from Earth. It's approximately 80,000 light years in diameter, so about 2/3 the diameter of the Milky Way. So just a bit smaller than our Milky Way, and 55 million light years away. And this is 1055. What if the annotation with that? Let's see what if that's what the annotation tells me. Nah, it doesn't tell me much or anything. Anyway, that one's 1055. So we will. Are you on? Yeah, you're on. Huh, funny. Okay, so NGC 1055. This is another spiral galaxy. Prominent nuclear bulge. A wide, knotty dark lane of gas and dust. So we're kind of looking just underneath the bottom of it. There's actually three other galaxies There's actually three other galaxies behind this that are much further away. It's estimated at 52 million light years away, with a diameter of about 115,000 light years, so about the same as the Milky Way. So 52 million, 55 million. And then M77, our last guy over here. This guy is about 47 million light years away. Discovered by Pierre Marchand in 1780. Both Messier and William Herschel described it as a star cluster. It's one of the brightest Seyfert galaxies visible from Earth. It's about 90,000 light years, so about 3/4 the size of the Milky Way. So there they all are, 55, 52, and 47 million light years away, left to right, and make a pretty nice picture. All very different galaxies. So it's got a very bright core, and then it quickly thins out to just a fuzzy outer ring, fuzzy outer halo of stars. Let's rebalance that. Bring that in there. Bring this over here. Make it pop out a little bit more. Alright, we'll try zooming in on this guy up here. See him a little bit better. Yeah, definitely a good bar in that. Definitely a good bar there, and then the spiral arms coming out from that point. So, thus being called a barred spiral. Some nice structure in that. That's about right. You could even stretch that a little more, I think. Hey, good evening, Mike. Thanks for stopping in. We've got a threefer going on right now. This is our actual target from the challenge, which is NGC 1073 here. It's our actual one, but we managed to, with a little bit of repositioning, to get a threefer. So we also got NGC 1055 down here, which is a galaxy, another spiral galaxy that we're looking at edge on, unlike 1073 where we're looking almost face on. And this has got a nice knotty dust lane above it here. In fact, I might back off on the stretch a little bit just to make that dust lane appear a little bit better. But it's a edge-on spiral galaxy. You can see the bulge, both top and bottom. Thanks you, Larry. Thank you for coming. Happy New Year to you as well. So it's got a nice central bulge there, and then a very dark, textured dust lane going all the way around it. Go in on it a bit. If it looks a little grainy, that's okay, because you can definitely see some texture in this. So, pretty cool. And this one is 52 million light years away. The first one we looked at, 1073, the barred spiral, that one's 55 million. This is 52 million light years away. So the light we're seeing from this was left 55 million years ago, long before humanity was a twinkle in anybody's eye. That's pretty cool. And then last but not least is M77 over here. A safer galaxy with a very bright central core that quickly dissipates to a thin halo of stars in the outer bands. But it is a spiral shape. But it's just there, those bands are out there. This is Charles Messier's 77th object in his list of things that were not comets that many of us now use to cut our teeth in astronomy when we're first starting, because his list is some of the most spectacular stuff that's out there. Some of the most spectacular objects that exist are on the Messier list. Now there's all three of them. Take one last look and then we'll move along to the next object. A threefer, like threefers. We obviously have another galaxy up here. So whoa. Wrong button. Obviously have another galaxy up there, but yeah, these are beauties. Almost hard to leave this. But we got to. Okay, let's go to this target. Fortunately, we're running up against a little bit of a clock, which is this red line. In fact, we're going to skip 1232 and go right to this guy here. Seems to be we got something in the southern sky too. No, this is what we're going to get. Where is? Yeah, this is the one in front. This is one of the southern members here. This is one of the ones that was in that Brent put for the southern sky. And you see 1097, which I can actually get here. Or Caldwell 67. Okay, yeah, well, you can see it right there. We don't even need to plate solve because we're there. So let's just do it. Let's just do it. 1097, a nice barred spiral with a bright companion. Yeah, well, I'm at about 36 degrees. You're at 31 latitude? Well, you should be. You're higher, you're lower than I am, so you should be able to get it as good as I, if not better than I. Scott says your colors are great to use a smaller refractor, 102. No, that's not smaller, that's actually a respectable size for EAA. A 533 MC, and my colors are often dull, unless I do a long exposure. Well, one trick, I don't know if you use any filters with your setup, but which likely you do, because 99% chance you're from a somewhat light polluted place. But for me, if I don't use at least a UVIR filter, I get lousy colors, or I get no colors, I should say. So UVIR really helps with colors. But like I said, if you are using some sort of light pollution or some other kind of filter already, then you're probably already getting that. And what helps also, as you can see over here, is I do have my saturation turned up in SharpCap. I'm at 1.7 instead of 1.0, which is flat. I do have my saturation turned up a bit. So that also helps too, is to just cheat a little bit and turn it up in software. You'll notice that there is a dark band here. 9 times out of 10, what's happening is it's one of the power lines or power poles, because this is low on my horizon. It's probably only going to be 20-25 degrees. In fact, we can look in here and see, yeah, it's about 25 degrees off my southern horizon. So I'm looking through power lines and power poles. So we're getting a little bit of a dark spot there, but that's okay, because we can just zoom in and get rid of it and pretend it's not even there. Very nice galaxy though, with companions. So I think he said is there 2 galaxies in here? Go ahead. Plate solve your little heart out. Well, there's a lot of other galaxies here, but they're all really puny. Uh-oh. Shouldn't have done that. Hopefully that my microphone still works. I got up and went to walk away and forgot to take my headset off, so he yanked that right off my head and across the computer, and anyway, I assume it's still working. It looks like it is. Sound meter seems to indicate it is. I wonder, it said something about a companion. This is an active galaxy. Yeah, there it is. There it is. Yeah, which is why this is pulling this one apart. This littler guy's, it's basically a galactic collision, and so it's pulling the big one apart. So, yeah, that's what's going on here. We've got 2 galaxies interacting and colliding. Okay, so whoops, wrong one. So we've got this one here, and yeah, so that was the southernmost one that we just did, 1073. That was a nice one. And so I think we're done with the ones. I think there was one up north here that was. No, wrong direction. Yeah, SH2. 200, but I've got a little bit of time on that one. I've got a little bit of time on that one, so we're okay there. Okay. Yeah, so we can do this one next, and then head up to that one. Then we've got a little bit of a breather. Hello, Fantasy X. How's things in Bakersfield? Oh, you're in Central Mass. Okay, yeah. Actually, you're from my neck of the woods. I'm from Southern New Hampshire originally. My folks are still there, and a little bit of family. Basically, well, the filter I'm using right now is just a ZWO UVIR cut. That's it, just a cheapo. I had a nice Optolong UVIR cut, and I sold a telescope and accidentally left it in the scope. So, bye-bye to that one. Yeah, I just use a ZWO UVIR cut. Nothing special. I use other filters. I have a Gen 1 NBZ that I use for when the moon is up and I want to do some nebulas and things. On my wide field rig, I have a Canon camera lens, a 200mm Canon camera lens. It's an f2.8 that I have basically stuck a 183 camera on the Astro camera on the back of, and on that one I have an Antlia ALPT, which is a 5nm dual band, narrow band filter, and so that one I do large nebulae and things like that, heart and soul nebula, etc., etc. You know, bigger stuff. But that's again when the moon is out. So. But those are really the three filters that I use. Don't need too much more than that out here. Obviously, I don't have light pollution to contend with, so in that way, I'm very lucky. Although Bortle 4.5 is not too bad. Lebanon, yeah. Couldn't afford astronomy then. Yeah. Yeah, when it comes to UVIR cuts, I don't think, you know, get on to Cloudy Nights Classifieds and pick up something, you know, 30, 40 bucks, 50 bucks if you're feeling rich. You know, it doesn't have to be anything terribly spectacular to be a UVIR. It seems to work just fine for me. At least. Other filters, yeah, well, that's different. I tend to stay away from the Optolong filters. I didn't have this problem with the UVIR cut, but when I've had the L Enhance, I've had the L Extreme. What else have I had? Anyway, my experience with them is that they just put halos around stars, around bright stars, and I didn't like that. And the Antlia filters don't do that. You know, I had an L Extreme and the Antlia ALPT. I had them at the same time. They're very similar. The L Extreme was a 7nm bandpass, and the ALPT was a 5mm, so a little bit more restrictive. But on the same night, I did the same objects with both filters, and found that the views I got from each of them was pretty much identical. The only difference was the halos. The L Extreme put up the halos, so that's just been my experience with the Optolong filters, is they just put halos around brighter stars. But the Antlia was a bit more expensive, but it was worth it because it didn't put any halos. So okay, so yeah, we're on 1097 right now. I suppose before we get off, I could look up a little bit about what 1097 is. And you see 1097. Tell you a little bit about it before we make it disappear. Barred spiral, 45 million light years away. In Fornax, William Herschel discovered it. 1790. It has a severely interacting galaxy with obvious tidal debris and distortions caused by interaction with the companion galaxy, which we just looked at, 1097A. So yeah, these two are severely interacting. No doubt what's pulling this one out of shape. Probably was a nice little spiral before it even barred. Before it, barred, yeah. Obviously, definitely an elongation here, probably a barred spiral before this second galaxy came in and messed things up. But that's pretty nice. Alright, we'll finish this sub and then we'll head on up. Very nice. Okay. Alright. Well, at 12:32, might as well get it done. We're here. Eye of God Galaxy. Alright. Yep, right there. I can see it already. So we'll just go. Okay, and we'll jump up and do this sharpless object. And then we've got, then we can take our time a little bit. We can do this one as well. It's still coming up, but... This is what? 12:32, and you see 12:32. Yeah. Nice one. Oh, you know what? This is power lines. Again, I'm still close enough to the horizon that I'm getting power lines in here. I think that's just a star being distorted by the power lines. Yeah. Pretty spiral, almost pinwheel-like. Well, it's rising, so hopefully the wires are going away and not toward. Guess we'll find out. The Eye of God Galaxy. This is an intermediate spiral, 60 million light-years away. Discovered by William Herschel in 1784. It's approximately 200,000 light-years across, so about double the size of our Milky Way. The arms are not perfectly even. There's one arm that kind of sticks out more, another arm here, than the other side which doesn't, so I think there's some kind of interaction maybe with another galaxy, but think we lucked out because the telephone wires look like they are going away. So they're not going to interfere with the galaxy. Just barely off the screen, but they're not going to interfere with it, so that's cool. Risk going in a little bit more. there's 10 minutes on this beauty. Getting some nice detail in the spiral arms. And you can see all the knots here of star formation. All these bright open clusters and areas of high energy star formation in here. Lots of stars happening, which is also an indication that this thing is gravitically active somehow. Something is interfering with it, pulling it apart, misshaping it, and causing a lot of energy that's causing a lot of star formation. So, pretty little galaxy. No doubt about that. We go off to next here. Okay, you guys are now crossed. Yeah, we need to do this one before it crosses. So we'll continue to walk our tightrope up the meridian, right near the Heart and Soul, or Bison nebulae up there. Okay, where are you? There are you. Alright. And let's... forgot to do that part. Okay. Right, and now we've got to make sure we plate solve on it, although I think I see something in there. Yeah, it's already in there. Well, we'll let it get perfectly centered up, and then we will go. Alright. 4 hours, 3 hours, yeah, so we've got maybe about 15 minutes. That should be just enough time. Although, this is going to be a sharpless object, so this will be another object that'll be, as a sharpless, it'll be an emission nebula. And so it's probably not going to be very strong without a narrowband filter. But we'll see what we can do. Looks like a bit of a dark space in there, but let's see what he has to say about it. Originally classified as an emission nebula, was rediscovered as a planetary. Oh, this is a planetary. Oh, large, faint, and apparently ancient planetary nebula. Large, faint, and ancient planetary nebula. Something in there, maybe? I'm gonna have to cheat and use annotation. Wow. And here's the Trumpler open cluster he was talking about over here. A little galaxy in there. We'll pull the Trumpler cluster in. That's a pretty thing. Well, we'll stack some subs and see where we get. See what we get to here. I'm not really seeing much of anything in there. reason I lost the feed of my own broadcast there for a minute. Back now. And I'm going to have to stretch this quite a bit more for you guys to see anything, although honestly I'm not seeing much of anything anyway. Oh yes, okay. I can just barely make out the faint fuzziness in here. I'm going to have to stretch this thing to within an inch of its life to get you guys to see it. But yes, you can see there's a fuzz cloud right in here. Right in here. There's a fuzzy cloud. I never would have seen this if it hadn't been pointed out by by Brent and this. It's very faint. Yeah, I can see I'm going to have to stretch it for you guys a bit more. It's very faint. Let's see if you can still see how that turns out when my screen updates. But it's very, very faint, so I'm having to really stretch the histogram a lot to get it to come out. But yeah, you can probably see it now. Just with this hazy, bluish looking cloud here, which Sharpless thought was originally an emission nebula, but turns out it's a planetary nebula, a very old one, where it's now gotten so big and dispersed that it's very diffuse and very faint. Huh, very interesting. And in order to be able to see this, we have to stretch it so hard we're kind of blowing out the Trumpler cluster, but still some pretty star colors up in it. Stars are kind of fuzzy at this histogram stretch level, but at least we can see SH200, SH200. Pretty cool. Let's watch our meridian here. Yeah, we're still doing just fine. Oh, thank you for the thumbs ups, guys. See, I got 8 thumbs up now. That might be a record for me. Thanks for the thumbs ups. Yeah, I just barely see it. I'm probably going to have to stretch it more because it's starting to darken a little bit as we get more data in. Keep it stretched, keep it really stretched, because it's very, very faint. Very, very faint. Ah, thank you, Fantasy. It's really just a diffuse cloud of color. That's all it is. Just, well, thank you, Tiffany. Appreciate you coming back and visiting me again. I just realized that when I went to go put this up, I knew I hadn't done one in a while, but it's been over 2 months since I've done a YouTube, so I've been, well, the weather, my schedule, blah, blah, blah. I haven't exactly been negligent, but good to get back. out for tonight. Thanks for the stream. Just some rain and snow melt. Too might actually get out tonight, so I appreciate that. You're welcome, Scott. Thanks for being here. I really appreciate you showing up. Hopefully it won't be very long till I do another one. I'll try and be more on it. Yeah, this is so faint. I never would have known that was there. That's just really faint. This one is, I think, our last one that we're kind of in a hurry to get to. Yeah, the next one, everything else has already gone over across. We've gotten all this stuff. I think the only other things, we've got the North American here, a couple of dark nebulae, and some, well, we've got 3 targets really close to each other out here. To the southeast. Minor and Sirius, which I can't even see yet. So, yeah, see, now we can slow down a lot. Now we can slow down a lot. Catch some other things while we wait for some of this deep stuff to rise. No, Fantasy, I did not get Andromeda, because it's not even on our list for this evening. So, nope, that one is not there. In fact, it's on the other side of the meridian at this point. It's out in here. So we've already flipped over. It's also a little bit too big for my view. So I don't usually get that one. I actually prefer Triangulum to Andromeda, because Triangulum fits nicely within my field of view, whereas Andromeda is just too big. I think we'll take this last sub and move on. We'll go from one thing to another, a very faint object to a very bright one. North American Nebula is a very bright object. In fact, it's another one that's too big for my field of view, but Alright. So, there is Sharpless 200, a very old, large, and diffuse planetary nebula. Our second one of the night. Alright, let's go look at oh, I'm sorry, it's not North American, it's California. Yeah, another one that I can't really get. It's too big for my field of view, so we'll try and get the more interesting bottom part of it. It's got a little bit more texture. Yeah, pretty much right on. Okay. Stay right where we are. So, this yellow rectangle is my field of view. California Nebula is way too big for it, so we're going to get this bottom half is a little bit more texture in the nebulosity. This is more just kind of fuzzy. So we'll get the bottom half of it. There we are. So the bottom wispy part of the California Nebula. Yeah, you can see there's some nice structure in there of nebulosity in this bottom half. Yeah, it is. It's a pretty one. It's got a nice color. Again, if you use a narrowband filter, it cuts a lot of these stars out. Eliminates a lot of them and just has the nebula itself pop through, but this one's not so thick a star field. It's terribly bothersome, so it works pretty well. And as a point of information, the reason this nebula is red is because it's mostly hydrogen. Most nebulae are either red or they're a bluish green, kind of like the Veil Nebula that we started out with. It was a combination of both. And the red is hydrogen, and the bluish green is oxygen. So this one is mostly hydrogen, although there are some lighter parts in it that could have a bit of oxygen in them. Some of these lighter spots, lighter veins in here could have some oxygen in them. And so they're showing up as a bit lighter, but the red is hydrogen. This is just to tell you a little bit about the California Nebula. It's about 1,000 light years from Earth, and the reason it's an emission nebula is because it is being irradiated by this star here, Xi Persei, or Menkev is also the name of it. This star is basically irradiating it and making it glow like that. So that's why we're seeing it like this. And it's kind of cool because the star is blue and it makes a nice contrast to the mostly hydrogen Okay. Well, that's pretty good there. I think, let's see what else we got. What we got over here? Well, we have, we've done those. Oh, I thought there was another one. Yeah, we've got a dark nebula here next to Orion. So, yeah, let's go pop down and do that dark nebula down there next. Is that going to do it? Yeah, so this dark nebula is what we're going to do next in here. Try and center this up a little bit better. Yeah, there we go. That's better. Okay. All right. Thank you, California Nebula. Beautiful, as always. And let's go to the next item on our list. Dark Nebula Object. LDN 1622. Let me know if you can hear me better now, Mike. The microphone might have drifted a little bit away from my mouth. But thank you for letting me know to any audio issues or anything going on. Hopefully you can hear me better now. Yeah, this mic is pretty sensitive to location, so I think it's a bit noise cancelling, so if it's too far away from my mouth, it thinks my voice is part of the background noise and attenuates it a bit. Okay, so a dark nebula. So this one's going to be, we went from a very faint large planetary nebula to a very bright nebula. Now back to a much more dim one again. Doink. Doink. Lots of nebulosity around here, but the one we're specifically looking at is the dark space in here. And actually we've got a little bit of reflection nebula, looks like around this star too. So yeah, it's going to take a few subs for this to come in and brighten up a bit. But it'll eventually come in. Dark nebula is usually more subtle. Because it really depends on how bright the surrounding stuff is. Dark nebulae is basically just dark dust and gases that are opaque and either light absorbing or light blocking. And so typically dark nebulae is something that is in the foreground and just blocking the nebulosity of what's behind it. In this case, in the area of Orion, the whole Orion area is a massive complex of gas and dust and a lot of stuff. There's a lot of star-forming regions that are around here. It's quite an area, and so there's a lot of nebulosity. Faint, some pretty darn bright. It's easier to see dark nebula because there's so much other color and residual gases in here. It looks like some of these stars have got some definite reflection nebula around them. As we get more subs in, we can stretch it a little more. Yeah, it's pretty thick stuff, or at least it absorbs light in some form or fashion. But you can see the dark nebula really shows up well. This is kind of interesting in here too. I wonder if that asterism has a name. Yeah, it does. It's a VDB 62. And each of these even has its own naming. I think 1621 what we are after. LDN 1622, the Boogeyman Nebula. The Boogeyman Nebula. 1622. Yeah, so this down here, this whole complex is called the Boogeyman Nebula. That's 1621 up there. I guess we'll just focus on this down here, especially since we've got this cool thing in there as well. Boogeyman Nebula. Yeah. Yep. Well, like I said, in the you're right. There is a lot going on in this field of view because, as I said, the whole Orion complex is just a lot here. Lots of gas and dust, lots of star-forming regions, lots of interesting things happening. It's one of the most active star-forming regions in the Milky Way. So, lots of stuff here. Building. We can go over and check out Casper for a minute. Our our final objects are, where am I? Oh, they're up here. Okay. So they're actually between Sirius and Orion. So I can just barely see Sirius now, opposite Mars. So they're out here. Yeah, so I just barely see it right now. So we'll have to maybe just spend a few more minutes on this. I zoomed in a little too much there unintentionally. Final objects. Can I get any of them in together? No. Seagull I won't even be able to get all of. I think I can probably get the top object at this point. Dark nebulae. There are people who just like hunting dark nebulae because it is kind of cool stuff. You know, it's not, when you understand it, the dark areas are not holes in the stars. That's actually dark dust and light-absorbing gases and whatnot that are blocking everything that's behind it. So it actually is nebulosity, just of a light-absorbing, light-blocking kind. Alright, I think I can get the top one of these objects now. LBN, well, whatever. Anyway, that'll be close enough. Let's make sure I just have stars in the whole field of view. Looks like I do. Alright, plate solve on that baby. Okay. And we'll get started. Do M50 next. That's a cluster, so that'll be nice and quick. And then the seagull will be our final object. I don't think we have any others. I think we've got everything else. Yep, so it'll be the final two. Final two. So LBN 1022. Let's see what he has to say about this. Near the seagull, and even close to the OC open cluster M50, all of which we're getting. A fairly bright emission nebula that was missed by Sharpless. Okay. Well, fairly bright, he says, huh? guess it must be this. I think it must be this up here. Fairly bright, huh? Well, I think it's mostly fairly small, but we'll get a few subs in and see how it looks. Well, definitely a faint one. Not nearly as big or bright as the last one, but definitely in there. Looks like sort of like a horse. Horse's head, tail, back legs, and front legs, or the galloping horsey. Yeah, I totally agree, Fantasy. That's one of the reasons why I like doing this stuff. Just gives you perspective of the awe that's in this universe, you know, and you know what we have, what part of this we are. I mean, you just look at this view. There's so much in this view. I mean, every one of these stars, and we can't see a lot of the stars that are in this view because they're too faint. Every one of these stars probably has some sort of satellites, if not planets, around them. And some of those planets will have life. Some of that life will be intelligent. And so you just, you know, it's like the old Carl Sagan thing. Even if 1 in a million, and 1 in a million, and 1 in a million, there still would be millions of civilizations out there because there's countless numbers of galaxies, and each having billions and billions of suns. I mean, there's just so much in this that we don't even, you know, we make our science and technology and whatnot, we make guesses about this stuff, but we don't even know. There's so much here. Even in a relatively boring little view like this, there's so much here that it's just amazing. Well, there's 10 minutes on that. I don't know that we're going to see much better than that. It's not a whole lot there, but definitely a nice dark nebula that's blocking out this mostly hydrogen nebulosity behind there. Even a little blue reflection or oxygen behind it. Probably being irradiated by this star. Or maybe one of these blue ones. Anyway, there we are. Now we'll go to something that's a lot brighter, M50. A heart-shaped cluster, or coil cluster. And for this one, another star cluster, so we're going to drop to 15-second exposure. And just go. And then drop you to 15 seconds. Clear you out. Open you. And then we'll shoot a little star cluster for a few minutes. Messier object number 50. Looks like a little nebulosity around here too. Messier 50, also known as the heart-shaped cluster. Opens cluster of stars in the constellation Monoceros. It was recorded by G.D. Cassini before 1711 and independently discovered by Charles Messier in 1772 while observing Biela's comet. It's sometimes described as a heart-shaped figure or a blunt arrowhead. It's about 2,900 light-years away from Earth. and is near to, but not narrowly. It is near to, but narrowly not estimated. Wow, narrowly not estimated to be gravitationally tied to the Canis Major Association. It has a core radius of 6 light years and spans a total of about 18 light years. Cluster has 508 confirmed and 109 probable members. It's around 140 million light years old. So somewhere between 500 and 600 members in total. It's in a dense enough star field where it doesn't really stand out very strongly, especially when you zoom in like this. It doesn't have a very bright core, but that's why this is an open cluster and not a globular cluster. And this is the biggest difference between an open cluster and a globular cluster is a globular cluster has a very thick, dense core, and an open cluster doesn't. It's just a tight, a loose to tight grouping of stars. I mean, it's a grouping of stars, but it's not very tight. A globular cluster, they're very tightly bound together, at least at the core, and then thin out as you go out. But an open cluster can be not that. It's just much more loosely tied, doesn't really even have much of a centralized core per se. Tonight has certainly turned out to be a very nice night. Yeah, it's hard to say. It's hard to say what the art. Of course, that when they were looking at it, way back when they were looking at it, you know, it probably is a much smaller object than what we look at it. But I'm also getting some vignetting here. I think the reason we're getting sort of a bright hazy spot in here is because this is, it's low on my horizon to the southeast. It's low to a white, it's low over a white building, my little storage shed. And so I think I'm getting some light reflecting off the front of that shed, making this kind of white here. Just getting some interesting nebulosity around some stars down here too. A little bit of star action down here. Some reflection nebula going on around these guys. But there's M50. Let's see if this fuzzy bright spot sticks around when I do the seagull, which is going to be even a little bit lower. And that's not too bad. Try to get as much of it in as I can. It's probably about as good as I'm going to get it right there. Alright. The seagull. A little bit too big for my field of view, but we'll see. Oh, wait. I know the problem. No, I know why we were getting it. Well, first of all, I need to do that because I didn't load the flat again. And even at 15 seconds, we were able to see that. So, that's why that bright spot was there. I changed profiles in the middle of this, so I'm not sure what we're going to see here. I'm not sure if this first sub will be messed up or not. Looks okay. The Seagull Nebula. Well, I think that's a dove, Tiffany, but close enough. I think we've gotten everything tonight. The Dusty Hand Galaxy. Did we do this one? 2146. The Dusty Hand Galaxy. That's the only one we didn't do. I just headed downhill, and I don't think we did 2146. But we did all the rest of these. Yep. Yep, we're doing the Seagull now. We did the Darks. We did California. We did it 1550. The double cluster, we did 79 at 4 and then 200, and we did 1097. These two here are Southern Hemisphere. We don't hope to get these. So yeah, we've got one more to make it complete. 2146, which is all the way in the northern sky. Do I have to do a meridian flip for that? No, it's on my side, so it's should be a good way to finish. Okay. Let's give you a good stretcheroo here. The Seagull. You can see this is mostly the red hydrogen emission nebula, but there is some blue reflection in this, a little bit of blue haze, a little bit of blue frosting around the hydrogen. Again, a galaxy that would be better captured with some filters that would knock the stars way back, make the smallest ones disappear entirely, which would really allow the nebulosity to come to the fore. Yeah, you couldn't find a gull. Hey, that's okay. You get an A for effort. I'm not sure this looked much like a seagull anyway, so your dove probably is closer to the seagull looking like than this thing is. Alright, there's the seagull. Now we're going to go do our last object, which is going to be a galaxy. The Dusty Hand Galaxy. Right, slewing up to the other end of the sky. Okay. And plate solve on that guy. Yeah. I think I caught a glimpse of it just before that. Alright, the Dusty Hand Galaxy. So this is NGC 2146. It's a barred spiral galaxy. The constellation Camelopardalis. Galaxy was discovered in 1876 by Friedrich August Theodor Winicke. It has a diameter of 80,000 light years, so about 2/3 the size of the Milky Way. The galaxy's most conspicuous feature is the dusty lanes of a spiral arm lying across the core of the galaxy as seen from our perspective. Biggest challenge, but this is going to be that's going to be small. It's going to be our biggest challenge, is that it's just going to be really small. Some pretty stuff. Ooh, more galaxies though. Our guy. There'll be some dust lanes in there somewhere, so we're going to need to gather some subs to have those show up. The arm is bent 45 degrees by a close encounter with a smaller galaxy. So earlier tonight we saw NGC 1055, which had a straight dust lane. Looking at it almost edge on, you can see this core, the bulge of the central core above and below the dust lane, but then the dark dust lane that was going all the way across the outer, basically the outer edge of the galaxy. It was edged in this dust lane of dark dust and gas, and so that's what they normally look like. Now this one is the same sort of galaxy, except it has been distorted by something. Possibly another galaxy. They think it's going to be another, well, a galaxy they call 2146A, and they're thinking about 800 million years ago these galaxies collided. So is that this one maybe? Let's see. Pull up our annotation. Yeah. So this one here. So they're thinking that this galaxy here collided with this one. As you can see, we've got a bunch of other smaller little galaxies here, but those are probably very much in the background. But they're basically thinking about 800 million years ago. This one passed by this one and highly distorted its shape. So that's why we've got a twofer here, because culprit that done it is still in the neighborhood. So we'll have to let this gather some subs before we'll be able to see any of that detail. If we can even see any of that detail. Might require more focal length than I have. Make sure you're on target there. definitely seeing a lot of brightness from the galaxy, but not seeing a whole lot in the way of the distorted dust lane. Not really getting much of any of that at all. So this object may be a fail. We're not really seeing any of the dark dust lane. Well, let's try backing the stretch off, seeing what that does. No, it just kind of distorts a little bit. Just kind of distorts it. If you look at the Hubble picture, you can see it's a lot. There's a lot of... Yeah, see these dark parts here are all part of the... Just barely see these dark parts. That's all part of the dark nebulosity that's in here. I've just way overstretched it. What we really want is to have it be not so stretched. You can see more of the dark. Anyway, you can see the dark structure is sort of all over the place. It's kind of all messed up, as opposed to that edge-on spiral at the NGC 1055 that we were looking at earlier tonight, where it's we really had that nice fine, straight, thin dust lane going all the way across it, and this one has just gotten really perturbed, and it's because that they're pretty sure that other galaxy swept right across it. So I think for this I would need more focal length, aka magnification, effectively magnification, to be able to see it better. But this at least gives you a bit of an idea of what we're looking at, just sort of a messed up dark dust lane that got distorted all over the place, along with the flat planar shape of the galaxy, which has gotten all misshapen. So very much an interactive galaxy kind of thing. So it is a pretty cool object. I don't have exactly the right setup to get it tonight, but it's pretty cool. It's a pretty cool object. Active galaxies are pretty interesting to look at. What's an active galaxy? It means it's probably interacted with something fairly recently, so it's all being pulled out of shape and torn out of shape, and interesting things happening with it. But on that note, I believe I'm going to call it a night. Been out for about 3.5 hours tonight. Certainly one of my longer live streams, but it's been such a gorgeous night that it's been really nice to be out here. We did not get bothered by any of the clouds that they were saying we were. Well, first they weren't saying we were going to get them, then they were saying we were going to get them, and it turned out we didn't get them. So it all turned out to be a very nice night. So thank you everyone for being here, and I will see you again soon, possibly even as early as tomorrow night. We will see. There's a lot of really cool stuff to look at up there still, and I haven't been on in a couple of months, so who knows, maybe even tomorrow night possibly, but stay tuned, and I will see you guys next time. Thank you for your time and for your views.